Hey everyone, welcome back to my channel. Today, we're diving into a fascinating topic that affects us all, especially those who love math or those with print disability: the ambiguity of spoken math. Whether you're a student, a teacher, or just a math enthusiast, this topic is sure to spark some interesting thoughts. So, let's get started. Have you ever been in a math class or a meeting where someone says a mathematical expression out loud, and you're left wondering what exactly they mean? It happens more often than you think. Spoken math can be incredibly ambiguous, and today, we'll explore why that is and how we can overcome this challenge. Let's look at some examples to understand where the ambiguity comes from. This time, let's make it interactive. Grab a paper and pen and try to guess the correct expression as I dictate it. You can pause and rewind the video as needed. Good luck!
Here is the first example. Try to write down the expression and we will check later if it matches with the correct expression. So the first expression is A plus B over C minus D. Again, it's A plus B over C minus D. For our second example, the expression is the square root of A minus B plus C. Again, it's the square root of A minus B plus C. For our third and last example, the expression is 2 raised to the power of 3 plus x raised to the power of 4 minus 7 equals 64. Again, it's 2 raised to the power of 3 plus x to the power of 4 minus 7 equals 64.
It's time to check your work. Here are the three expressions from the previous slides. Did you get all three correct? If you did, great job. However, if you only got 2, 1, or even none correct, that's perfectly fine. Many people find it challenging to get the correct expressions. For the first example, there are at least 4 possible ways to write the given expression. We can have both variables, a and b, in the numerator. Another possibility is to have both variables c and d in the denominator. This can certainly create some ambiguity. In the second example, there are at least 3 ways to write the expression. One way is with only one variable enclosed in the radical sign, that is the variable a. Another way is with 2 variables inside the radical. In this case, the variables a and b. The last way is with all 3 variables enclosed in the radical sign. This too can clearly pose ambiguity. Finally, the third example has also at least 3 possible interpretations. One is the one shown on our screen, which depicts that 2 has a binomial exponent, that is 3 plus x to the power of 4. Another is when we only have 3 as the exponent of 2 and the other terms are on the baseline. Last variation is when we have 2 as our base and all the other terms including minus 7 are the exponents of 2. This also shows a clear example of ambiguity in spoken math expressions. Ambiguity in spoken math is a possible barrier to the acquisition of knowledge for students who have print disabilities, such as blindness, visual impairments, and some specific learning disabilities, and rely on auditory input for learning. Mathematics appears to have considerable potential for being spoken ambiguously and may be a barrier to accessing knowledge and to learning. Educators in mathematics may be unaware of, or have limited awareness of, potential ambiguity in speaking math expressions and may speak ambiguously to their students. Here are some of the solutions that can reduce or possibly eliminate ambiguity in spoken math. One solution is to use clear and precise language in speaking math. For example, instead of saying A plus B over C, we can say the sum of A and B over C. In this way, we are able to convey the precise expression. Another solution is to use MathSpeak rules. MathSpeak is a set of rules designed to translate mathematical notation into a spoken language format that can be understood by users, particularly those who are blind or visually impaired. These rules provide a consistent way to describe mathematical symbols and expressions, making it easier for users to access and understand mathematical content. For example, the expression below can be read using MathSpeak as start root A minus B end root plus C. With this, ambiguity is reduced. On the other hand, a more practical solution is to write down the expression or use visual aids whenever possible. For students who are blind or low vision, it is deemed essential to give a written braille or large print equivalent of the expressions spoken. Finally, in educational settings, it is important to encourage students to ask for clarification if they're unsure about a spoken expression. To sum up, the ambiguity of spoken math is a real challenge, but with careful attention to language and notation, we can minimize misunderstandings. And remember, this is especially important for supporting our blind and visually impaired peers. I hope this vlog has given you some insight into this interesting topic. If you have any questions or thoughts, leave them in the comments below. Don't forget to like, share, and subscribe for more math content.